Example 3. The statement of the question is actually a bit long, but it's not a problem. It's a pretty standard experimental procedure, and it's something that you may run across. So a 20.0 milligram sample of a biological macromolecule, and by biological macromolecule, I mean a protein. It could be a nucleic acid, RNA, DNA. Could be a very large sugar. Macromolecule was dissolved in enough water to make 25.0, let's write that a little bit better, to make 25.0 milliliters of solution. Okay, so I have 20 milligrams of this biological macromolecule. Let's just say it's a protein. We dissolve it in enough water. We bring the volume to 25 milliliters. Okay, the osmotic pressure was measured, which we can measure it, was measured to be 0.56 atmospheres. That's actually pretty high for a solution at 25 degrees Celsius. At 25 degrees Celsius, my question is, what is the molar mass of the protein? And this is a standard experimental procedure for determining the molar mass of a protein. Well, it used to be. Nowadays we just use mass spectrometry, but that's fine. What is the molar mass? Again, if you don't have a mass spectrometer in your lab, this is what you do. Molar mass of the molecule. Well, what's our equation? Our equation is osmotic pressure equals molarity times R times temperature Kelvin. It equals the moles of solute. By definition, the molarity is moles of solute over the volume times R times the temperature. Therefore, again, I have the mass of this thing. I have the mass. What I need to do is find the moles. And if I take the mass divided by the moles, that's molar mass, grams per mole. So I'm going to rearrange this equation. So I'm going to solve moles of solute equals the osmotic pressure times the volume divided by R and divided by T. Does this kind of look familiar? PV over RT. PV equals nRT. Number of moles equals pressure times volume over R times temperature. Notice it's the same form as the gas law, except this is not a gas pressure, this is an osmotic pressure, but it's still a unit of pressure. It's pretty extraordinary, isn't it? That for a solution and a gas, things that you wouldn't expect to behave the same, they actually have the same form of the equation. Wow, that's pretty amazing. Okay, 0.56 atmospheres times 0.025 liters, right? Because whenever we use the gas constant, 0.08206, our pressure has to be in atmospheres and our volume has to be in liters. So 25 milliliters, I have to call it 0.025 liters. So again, watch your units. There's a lot to keep track of. It's not difficult, it's just tedious. There's a lot of little things, a lot of detail in these. Over 0.08206 liter atmosphere per mole Kelvin. I'll leave that off. And 25 degrees Celsius. Yes, 25 degrees Celsius. In Kelvin, it is 298. Is that right? Yes, 298 is correct. So the moles of solute equals 7.53 times 10 to the negative 7 mole. Very, very, very tiny amount. Well, now that we have the moles, we have the milligrams, let's go ahead and do some division. So, molar mass, which is what we want, it's equal to 20 milligrams, which is 20.0 times 10 to the negative 3 grams. I just use the definition of milligram instead of doing the conversion. I'm perfectly free to do that. Divided by 7.53 times 10 to the negative 7 mole. When we do that division, we get 2.66 times 10 to the 4th grams per mole. That is huge, 2,660 grams per mole. That's actually pretty small for a protein. So there you go. Osmotic pressure was used by using the definition of part of it, molarity, moles per liter. This is the kind of stuff that you'll see on the experimental section of the AP exam. Take a look at the equation. If the equation has something like molarity, molality, it's defined by something. Molality is moles of solute or kilograms of solvent. Write out the entire equation with each component of that particular thing, and then see what you need, and you'll get what you want. So 2.66 times 10 to the 4 grams per mole, that is the molar mass of our particular protein using a colligative property, in this case, osmotic pressure. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.